Hi friends, welcome back. Today we're talking about simplifying radicals. There are two methods to do this. Well, there's several methods, but I'm going to show you two methods to do this. If you haven't done so already, grab your notebook. Make sure that you have all your perfect squares written down because that's really going to help you when we do this. All right, let's talk about these examples we have here. So for our first method, we have the square root of 20. What you can do here is a little bit of side work. We're going to break down 20 into its prime factors. So two things that multiply to give us 20 would be 2 and 10. 2 is prime, so I'm going to circle it. 2 and 5 multiplied together give me 10. So I'm going to circle my 2 and 5 because both of those are prime. So our prime factorization of 20 is 2 squared, because there's 2 of them, times 5. Now, so what we have here is the square root of 2 squared times 5, because that is the exact same thing as 20. If you break that up to say 2 squared times the square root of 5, the square root of 2 squared, these guys cancel out and you're left with 2 root 5. So you can use your prime factorization to to simplify your radical, or the second method, which is the one I prefer and I'll probably be using throughout this, is that we will find the largest perfect square that is hidden within our root here. So we look at root 20 and I go through, and remember our perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, so on and so forth, right? So I look and I see, well, 4 I know goes into 20. 9 does not, 16 does not, 25 is too big, so it has to be root 4 root 5, because 4 times 5 will give me 20. So these two things are exactly the same, right? Now, the square root of 4 we know is 2, and you'll notice I drew a line through it. That's because oftentimes I watch students accidentally bring their radical down after they've square rooted. They've done the operation and they bring it down. And I don't want you to do that. So when you have a perfect square and you're square rooting it, cross that out and that'll help. Either way, we get the same answer here. Now, let's try practicing some of these other examples. For root 80, again, we're going to try and find the largest perfect square here. Now, looking at this, we can, if we divide by 4, we absolutely know that root 4 goes into it, right? We get root 4, root 20. But inside root 20 is another hidden perfect square, another 4. So we have root 4, root 4, root 5. 4 times 4 is going to give us root 16. So our largest perfect square was 16. So the square root of 16 we know is 4 root 5. Okay, so let's try with 72. So if we sit here and look at these guys, we could do 8 times 9. That would definitely work. 9 is a perfect square. So we say, oh, okay, we get perfect square. So that's 3 root 8. Now, you have to ask yourself, did I get all of my perfect squares? Are there any other hidden perfect squares in root 8? And looking back at our cheat sheet, I see a 4. So 3, and then we have root 4 times root 2 will give you root 8. The square root of 4 is 2. So I have 3 times 2 times root 2. So I have 6 root 2. What we could have done is chosen root 36. So over here, if we had root 72, root 36 times root 2 will give us 6 root 2. So it's a good idea to choose the largest one that you can, so that you it makes it a little bit easier for you. Okay, let's talk about this example. We have 3 times root 150. Now I love it when it looks like something that could be $1 or quarters, like $1.50, $1.75, $1.25, things like that, because we know our perfect square is 25 or 100 if it's a lot. So if it's like 500, things like that. So we look at this and I think, oh, 25 goes into that. So root 3, root 25, and if I have $1.50, that means I have 6 quarters. So 6 times 25 would give me 150. So this guy, we know that the square root of 25 is 5, so I have 3 times 5 root 6, and that gives me 15 root 6. All right, if you have any questions, let your teacher know. Otherwise, we will see you next time.